Okay, for the following quadratics, state the axis of symmetry, find the coordinates of the vertex, find the axis intercepts, and hence sketch the quadratic. Okay, so if we look at the first one, we have x squared take 8x plus 7. So if we're going to state the axis of symmetry, so before we start these, there's two things we need to know. Okay, and the first one is axis of symmetry. Okay, has the formula, which we should all be very familiar with. X equals minus b on 2a. Okay, x equals minus b on 2a. And the coordinates of the vertex, so the vertex has x coordinate that is the same as the axis of symmetry, minus b on 2a. Okay, and this makes sense. Okay, so if we have a quadratic function, all right, this is the axis of symmetry. All right, the axis of symmetry is the x coordinate is exactly the same as the minimum point, or the point of vertex. Okay, so for the first one, let's find the axis of symmetry just by using our equations. Okay, so we've got a, b, and c. Now, for the axis of symmetry, x is equal to minus b, which is minus 8, on 2 times a, which is 1. Okay, so we have minus 8 is positive 8 on 2, which is just 4. Alright, so when x equals 4, we have an axis of symmetry, which means the vertex occurs when x equals 4. Okay, so that's part, I'll write it out how they've written it so that we can keep track of what part we're doing. Okay, so the vertex occurs when x equals 4, as we deduced before. So all we have to do is put x equals 4 into the equation. So we go y equals 4 squared, take 8 times 4, plus 7. Okay, 4 squared is 16, 8 fours are 32, and then plus 7. So we've got minus 16 plus 7 is minus 9. Okay, so this means we've got vertex occurs when x is 4 and y is minus 9. Alright, vertex is 4, y is minus 9. Okay, part 3, find the axis intercepts. Alright, and the axis intercepts just occur when y is 0, so there's a number of ways of doing that. You could use quadratic formula, you could factorize it, or you could even use your calculator. Alright, for this one, I see that I can factorize that pretty easily. So we'll use the cross product method. So we've got multiples of x and x and multiples of 7, 7 and 1, and of course minus 7 and minus 1. So these are going to be our factors. Okay, the way the cross product method works is if I have, I say, what are multiples of x squared? Well, x and x. What are multiples of 7? Well, minus 7 and minus 1. And then I cross multiply. Okay, so x times minus 7 is minus 7x, and x times minus 1 is minus x. And then I add these together and I get minus 8x. Okay, so the product, minus 7 times minus 1, is positive 7, which is our c value. And the sum is minus 7x take x, which is minus 8x. Okay, so our factors are x take 7 and x take 1, of course, which makes the roots equal to 7 and 1. Alright, so we've found the axis, the x-axis intercepts. Now the y-intercept occurs when x is 0. Okay. So if we put 0 into this equation, x squared take 8x plus 7, we're going to just have y equals 7. Okay. Alright, part 4, hence sketch the quadratic. So we've got all this information here that we can sketch onto our Cartesian plane. So we know that the axis, the vertex, is at x is 4, y is minus 9. Okay, so when we're x is 4, about here, and x is 4, y is minus 9, down here. Okay, and then we know that the y-intercept is positive 7. Okay, positive 7. So that might be all the way up here. Alright, so there's our vertex, there's our y-intercept, and our x-intercepts are x is 7 and x is 1. So if that's 4, 7 might be about here, and 1 might be about here. Okay, we also know we've got, so let's trace through. So it goes through this point, and through this 7 point, and it keeps going, and the same going this way, goes through that 7 and keeps going, and we have the axis of symmetry about the point minus 4. That's terrible. Okay, so so we've deduced all that information about the graph and been able to successfully graph it.